Hello everyone, welcome to the coding manual, and today we are going to discuss about deleting a node in a given linked list. And this time we will be studying the deleting a node at a given index. So let's understand that. So deleting a node at a given index is, first we need to find that particular, we need to go to that particular node where that index is, and we need to link the previous node to the next of the node we have to delete. Okay, so there are some corner cases we need to look over that. First we need to check whether link linked list is present or not. So we need to consider whether the head of that linked list is not none, and the other case might be we need to delete the node at the zero index. That means we need to delete the head itself, so we need to move the head next to the head. And other case might be deleting a node which is beyond head. Okay, so let's get into this. So we have given a linked list and we need to delete, okay, one one node at given index. Suppose this is 1 2 3 4 5, and this is represented as head, and this is 0 1 2 3 and 4. Okay, so if we need to delete the head, what do we need to do is the head, if we need to delete, so we have to make this, mark this as a temp. Okay, or better, mark this as previous node, and then move the head to the next of previous node. Okay, next of previous node is 1. So since we have marked this like previous as not, we will see just head. So what do we need to do? If we need to delete the zero index, so we need to move the head next of previous. Okay, so mark this previous as head and then move the head as next of previous. Okay, and then make the previous, because now head is moved here. So after this statement it goes moved here, and now we need to, now this is temp because the previous statement says that uh, the previous node has been assigned as head, and then head is moved to next of previous. Now this is uh, previous, so just make this as none. So what do we need to do? Previous make as none. So your deleting at index 0 is done. Now so before that we had to check whether linked list exists or not. So we need to check if head is not none, then proceed, or if head is none, then return, because you do not have anything. You have defined a head, but this points to none, means that head itself is none. So we cannot delete, we do not have any index, we cannot delete a node from that linked list. Okay, so this is the first case, this is second case, and now the third case comes like we need to delete a node for which the index is beyond head. Okay, so in that case, suppose we need to delete this third node at index as third, given index is 3, we need to delete that. So what we'll do, we will try to find the previous of the given node. So we'll try to find this and we'll try to link this to the node we found, the next of the node we found. Okay, means the previous of the node we found should point to the next of the node we found. Okay, so in that case what we will do, so we will mark previous as head. Okay, and we will loop through 0 to index minus 1. Okay, and then we will do move ahead. So it's a traversing of list, previous of next, and we will check like when we move, so we are not reaching at the end, so we need to check that part. If previous is none, then we need to break that. Okay, we need to come out of the loop because we have found the end. Okay, so this logic actually takes us to the previous of uh, that index, and after that we need to check if previous we need to check previous is not null and previous of next does exist. So in that case, previous will become the node we have to find, and the node which we need to delete, that will be next of previous. Okay, so we are moving ahead this line, we are moving ahead this line, and then we need to check if previous is none or previous of next is none, then we will return. Okay, because in this case we have the index given to us is more than the length of the linked list we have. Okay, so this is checking. We will see the in the code, it will be more easier to understand there. Okay, if in this case we have found, since this is not true, so what we will do, we will mark as the next node as previous next 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 of previous, means we have to find this. So the next node, what will be, next node will be the, since previous is here, so next node will be the node we have to delete, dot next. So this goes here, dot next, this goes here. So next node we will be having this this particular node, and what we need to do is we need to delete previous dot next, means this particular node we need to make as none, and then again previous dot next, link this to this, the next we have found next node. Okay, so we'll try to understand via code. I think I have to open code. Okay, so just I'll create delete at index.py, delete at index.py. So create a class, just a moment. I'll increase the, okay, now the self dot data is data, and then self dot next is none. Now class linked list, okay. So these are the constructor, we are just assigning some predefined things. Okay, define insert node equal to, so we are using the node class here. So node class will create a node for which the data will be data and next will be uh, the next will be nothing. So one node we have created. So for simplicity we are using just inserting the node as beginning, because main thing we have to see here is to delete the given node at an index. So inserted begin, what will happen is self that head will always move back. So what we'll do is node dot next is self dot head, and self dot head becomes node. Okay, delete at index. So first check self dot head is none, then just return, because list itself is empty, so we cannot do anything. Now previous will be self dot head. We are taking a variable in which we are storing the head. Now check if index itself we are index 0 itself we are the head itself we need to delete. So what we will do, so we need to move the head one forward. Okay, so we have stored head as previous. So what do we need to do is self dot head, the head will move to next of previous. Okay, next of previous, and then delete the delete the delete this node. So what happened is head was here and previous was also here. So what we made is we made head to point to next of head, and then delete the previous. Okay, now I will just this. Now the next is the index is beyond the 0 index, so we'll loop through and we'll try to find the previous node. For I in range of index -1, and then previous equal to previous dot next, and we'll check if previous is none, then okay. Now if check if previous is none or previous dot next is none, then return, because we have moved beyond the in this logic we have moved beyond the link end. Okay, and not move beyond the end if we have actually traversed till index -1, and if the previous has reached previous or the previous of next is reached at the end. So that's what we checked here, and we need to return because we cannot delete which is beyond the end. Okay, now what we need to do is next node we have to, if nothing of none of this is means this previous is not none and previous of next also not none, so we will have some node to delete which is in the range of index. Okay, next node is going to be next of previous. Okay, and then we need to previous of next of previous means the we have a node at an index given index less than 1, means the given index is suppose 4, so we have a node which is at 3, so that is previous. Okay, so next of previous is the node we need to delete, so that we are going to make as none, and then again the next of previous should point to the next of the node we found which was at 4. Okay, so previous of next should, that's line 28. In this case we had like previous is here. If previous is pointing to 3, so next of previous is 4, and next of that is 5. So what happens, so next node becomes, previous is at 3, next node becomes, next of this becomes node we need to delete, and next of that becomes node we need to link to the previous. Okay, so we need to make previous dot next becomes the next node. Okay, now we will quickly check that. Before that we need to write one method which is print list. Okay, so just take the temp as self dot head, and while temp print, oh just a moment, I'll move little bit, then and then temp equal to temp dot next. Okay, ll dot insert at begin, suppose 5, and then copy 4 3 2 1 0 0 1 2 3 4, and we need to delete at an index of 4. Now print list, we should be able to see 1 2 3 0 1 2 3 5. Okay, so just control backtick, and now we are ready to run. Go to Python, and then Python delete at index. Okay, node takes no arguments. Okay, we need to see what is the error. This is wrong here. Okay, now let install this. Terminal, let it finish, then we'll run all program. Okay, we are expecting 0 1 2 3 5 because at index 4 we are deleting the node. Okay, just a moment. So if we go through this logic, let me do this. I think it's small, but to cover this I'm just making it. So this is the program we have written. Let's see if works out. This time Python delete at 0 1 2 3 5. Okay, as we said, so this prints out the correct output. Now let's delete at index 0. Okay, so we are expecting 1 2 3 4 5. 1 2 3 4 5. Okay, let's delete at index 5. Okay, it's gone. Let's delete. Okay, we have checked the head, and suppose if we don't have anything, okay, then list itself is not there, means head is pointing to none. So what we need to, we are not expecting anything, so we will give proper message. I think I need to save, and then we are not expecting anything, it was not saved. So let's say print list is empty. Okay, and suppose we are deleting something which is beyond the length of linked list, so we need to say given given index is beyond length of list. Okay, now suppose we have this and we are deleting only one, head is pointing to 5 and we are deleting an index which is 5 beyond length of linked list. So given index is beyond length of list and we could not do anything, we could not delete anything, so this method print list prints out 5. Okay, and list is empty, and this we have already seen. Okay, the list is empty. Okay, so this was very simple. Okay, this is really simple program, and we just need to traverse through the logic and traverse through the, let's delete this, the complete program will come into the picture. Okay, so this was really simple. If we go through the logic properly and what we have discussed here, it'll make sense more. So I hope you like the video, and please subscribe to my channel. Thanks for the day.